Okay, today we're going to talk about BOD. Again, my name is Stu Hannum. I'm a teacher naturalist here at Riveredge Nature Center. Here we are at the farm pond again. And what we're going to do is measure something called BOD. Again, BOD is really a fairly simple test. And the nice thing about it is that you probably already did the oxygen test. So this just uses that information and you just have to do it twice is all that you do. So we're going to run that through you. First of all, BOD is just an acronym. It stands for Biochemical Oxygen Demand. And so what we know for certain is that bacteria, many of them are aerobic, meaning they like oxygen. And so what they'll do is if you put them in a container with something they can eat, food, they'll gobble up your oxygen on them. And that's what we're going to take advantage of, those greedy little bacteria. All right, now, what this is truly measuring is the organics in your water. What are organics? Natural things can be organics, like we get leaves in water all the time. It's just a common thing. Twigs, we get twigs in water. It has to eventually get broken down. Those leaves completely break down. Eventually they end up disintegrating, and it's the bacteria who do that. So that's natural. We expect that, okay? We can also, though, have human waste that can contribute to that factor. The human waste could be things like feces and things of that sort, different things that we put into the water, different types of waste. So there's a lot of things, but generally speaking, we want to keep our organics in our rivers fairly low. We don't want them to be zero, but we want them fairly low, okay? All right, so that's the biochemical oxygen demand. That's the test we're going to do. And guys, here's the bottom line. It's really pretty simple. What we're going to do is we're going to just do an oxygen sample test on some water and find out how much oxygen is in the water. You did that already. Then what we're going to do is we're going to take a bottle of water and we're going to let it sit for 5 days. When it sits for 5 days, these little bacteria guys that are in this water are going to gobble up the organics, and we would expect that if there were any bacteria in there, our oxygen level would go down. That's what we would expect. If the oxygen level doesn't go down and stays the same, we've got no organics in our water. There's nothing for the bacteria to live off of. So it's about as simple as that. You might wonder, well, why is he holding a silver bottle? Okay, the bottle doesn't have to be silver. With my students, what I used to always do is I just had a bottle and I put it in a dark cabinet. You can use this if you don't have a nice dark cabinet to put it into. It's just aluminum foil. The point is we don't want sunlight getting in here. Sunlight, if we have any types of algae or anything, which we undoubtedly will, those things are going to cause photosynthesis and they're going to raise the oxygen level. We don't want that. What we want to know is organics and let the bacteria gobble up the oxygen. So it's about as simple as that. So guys, here's what we're going to do. You've already seen a dissolved oxygen kit. If you're not sure how to do a dissolved oxygen test, go back to the video that we have on dissolved oxygen and you can see how to perform that test. With my students, what I always did was I performed a dissolved oxygen test, one of the first things we did in our class, and we had that number, that milligrams per liter. So now I had that. And when I did to my students, when we got to the BOD part, was I took a bottle like this. I actually took a bottle just like this here. And all I did was I filled this with water. So if I go down to my pond here and I fill this with water, like so, then what I do is I gently put a stopper on top so that there's no air bubbles. Again, I don't want air bubbles because if I've got air bubbles in there, then I'll be measuring the air that we have in the oxygen here, and I don't want that. So there's my sample. That water, undoubtedly from the pond, has organics in it. It doesn't look like it. It's perfectly clear, but you surely would not take a drink of that because there's all kinds of things that could be in there. So what you're going to want to do with this water that you have here now, just as simple as can be, find yourself either some aluminum foil like this and coat it, or just put it in a dark cabinet for 5 days and forget about it for 5 days. Let it sit for 5 days. Okay? After you're done, it's 5 days later now. So we're pretending. After 5 days, we bring this bottle out. If there was any organics in here, the bacteria will have lowered our oxygen content. So now what we do is we take the top off this and we go right ahead and we perform a dissolved oxygen test on this bottle. When we perform that test, let's say for instance we had 12 milligrams per liter 5 days earlier in another bottle we did. And then after waiting 5 days, it was down to 10 milligrams per liter. That means that the bacteria gobbled up 2 milligrams per liter. Okay? So now, we perform this test, we get 10, we get a difference, we subtract the 12 milligrams per liter minus 10 milligrams per liter. On here, chart number 4, we have then, we're looking at the difference between the two. That's down here in the bottom. That is a quantitative number, 2. Now, notice 0 to 5 is pretty narrow there, so you're going to have to do some guesstimating. Take a straight edge, run it up till it intersects with this line, run it across, and I would get a number somewhere between 80 and 7. That's a Q value. Again, it's like a test score. If you get between an 80 and a 70, you're probably looking at a score. In this particular case, that's probably maybe around a C or so, okay, something like that. Let's say that you had done the 2 tests and you got 12 milligrams twice. You subtracted and you got 0. Well, 0 would be a perfect score. You'd be up here and you get 100. Let's say, for instance, you measured and you only had 2 milligrams per liter. You lost 10. Wow, we get a horrible score between 30 and 40. That's what we're measuring here. We're trying to measure how much organics was in this water. It is a very simple test, assuming you understood how to do the dissolved oxygen test. This is just doing that test twice. There's all that there is to that. Okay? You'll calculate your Q value and then you'll enter that into your data sheet. Okay? So that's all I have to say about this test today.